Number 9, have an application problem. The distance that a free-falling object falls is directly proportional. So we're going to say the distance because that's what they give us. So whatever variables that they, or whatever words they use, that's what you want to use to denote your variable. So the distance is what we're given, that the free-falling object falls is directly proportional to the square of the time it falls before it hits the ground. So what I'm going to write for number 9 is D, and this pen is fading. So D divided by T squared, the time it falls, is equal to K, directly proportional. So whenever you see directly proportional, you can also write that as direct variation. So you could also write it like this: D equals K times T squared. You would get the same thing if you multiply it by T squared. So that directly is what gives you the setup. So I'm going to go ahead and write it like this: directly proportional, as in direct variation. And then if the object falls, or if the object fell 47 feet in 4 seconds, so the distance is 47 and the time is 4 seconds, so it would be K times 4 squared. We want to know how far will it have fallen in 9 seconds. So we're going to solve for K. So this is going to be 47 equals K times 16. We're going to divide by 16, and that will give us 47 over 16 is equal to K. So K equals 47 over 16. All right, and then now we want to know how far will it have fallen. So I want to know D, what is the distance? And then K was, so using this formula, 47 over 16. How far will it have fallen? I'm going to multiply by T squared. T is 9 squared. So I'm going to do 47 over 16 times 81. And that will give me my distance. So D equals, we'll just use a calculator because we're going to have some decimals there. So I'm going to do 47 divided by 16, and then times 81. That will give us 237 feet, 0.94, 237.94. All right, number 10, music store manager observes that the number of CDs sold seems to vary inversely. So the number of CDs sold, I guess we can use CD for the number sold, or we can use S for the number sold. I'll use S. The number sold varies inversely, so that is K divided by something to the price. So I'm going to put P for price. If the store sells 660, so we're going to have 660 is what we sold. Within a week, the price is 18. So that is K over 18. All right, and then when we want to solve for K, we're going to multiply by 18 on both sides. And that will give us 18 times 660. We'll get a pretty big number. 18 times 660. You get 11,880. 11,880. So K equals 11,880. All right, so if this is the case, We want to know how many do they expect to sell. So S is what we're looking for. How many do they expect to sell? K is 11,880. How many do they expect to sell if they lower the price to $14.50? So we're going to have 11,880 divided by $14.50, and that will give us how many we would expect to sell. So I already have that 11,880 here. I'm just going to do divide by 14.5. And that gives us, and what does it say? Round to the nearest integer. Now, usually with real world, since you're going to sell 819, you would generally round that up because 0.3 means you would, sell 820. But since it says round to the nearest integer, we're just going to round to 819.